Hello guys, so conservation of energy problems. So a physics student is dropped if they reach the floor at the speed of 3.2 meters per second. From what height did they fall? A property of energy in a system is that it is conserved. So the magnitude of energy at the start of the system towards the final moment in the system, they would remain the same because they're conserved. So the E initial should equal to E final. So initially it is dropped. So it is not moving initially. It is yet to be dropped. It is dropped at a certain height. That means it's a gravitational potential energy. Potential energy. P stands for potential energy. And then finally, when it reaches the ground, there's no gravitational potential energy since it's at the ground, but it reaches it with the velocity, which means it's kinetic energy. So E kinetic final. And we'll plug in the equations for these specific energies and isolate for the height. So in gravitational potential energy, we know that it's the force times the height traveled. So the force of gravity is mg times the height traveled is h. And that is equal to the kinetic energy, which the formula is 1 over 2 mv squared. We can cancel out m from both sides, and then we can isolate for h. So h is equal to v squared over 2g. So let's plug in the values for velocity and the acceleration due to gravity, and then let's solve for h squared, and then h should equal squared divided by 2, which is 0.5. I'll leave it at how many significant figures? 2 significant figures. So 0.52 should be the answer. 0.52 meters. So now the second question. A heavy object is dropped from a vertical height of 8 meters. What is the speed when it hits the ground? So a heavy object dropped from a vertical height of 8 meters. This time we're given the height. Now we have to find the speed when it hits the ground. So similarly, the initial energy should equal the final energy in the system. The initial energy is the energy of gravity, the gravitational potential energy. And the final is the kinetic energy. So we know that the gravitational potential energy is equal to mgh, and kinetic energy is equal to 1 over 2 mv squared. We can isolate for v. So v is equal to, let's cancel m from both sides first. So v is equal to 2 times g times h, and then square root. There's g times h, and then square root. We can plug in the values for g and h. So 2 times 9.8 meters per second squared times h, which is 8.0 meters, which equals to 12.521 meters per second. But we should put it at 2 significant digits, so it should be 13 meters per second. Next question. So a bowling ball is dropped from the top of a building. If it hits the ground with a speed of 37.0 meters per second, how tall was the building? Very similar question to what we've been doing so far. So the E initial equals E final. It's gravitational potential energy at the start. There's kinetic energy. Then mgh equals 1 over 2 mv squared. It's important to show your works to get the full marks, you know. H equals squared over 2g. 37. This should give us 69.846 meters, but we need 3 significant digits, so 69.8 meters should be our final answer. So a safe is hurled down from the top of a 1.3 times 10 to the 2 meters building at a speed of 11.0 meters per second. What is the velocity as it hits the ground? So now there is a initial speed. So that means at the start the question is a bit different. So now at the start there is also kinetic energy as well as gravitational potential energy. So there is Eg initial plus Ek initial. And as it hits the ground, when it hits the ground, there's no potential energy because it's at the ground, but there is a kinetic energy. So let's find the final velocity when it hits the ground. So the mgh plus 1 over 2 mv squared equals ekf, which is 1 over 2 mv2 squared. We cancel out m's and we isolate for the v2. So gh plus 1 over 2 v squared times 2, then full rooted, equals v. So v is equal to, I'll just plug in the numbers through my calculator. It's too lazy. 2 times 9.8 times 2. But why does it keep doing this? That should give us 51 point. How many sig figs are we doing? We are doing 2 sig figs, so it should give us 52 meters per second. Oh my god. Okay. So a box slides down a frictionless ramp. If it starts at rest, what is its speed at the bottom? So we can use it again. So E initial should equal E final. Since it's conservation of energy, this is a very important formula throughout all these questions. So the initial speed, initially it starts at rest, so there is no kinetic energy, but there is a gravitational potential energy. So let's note that down. Gravitational potential energy initial, and then at the end, it's towards the bottom. It should have no gravitational potential energy, but it will have a kinetic energy because it has a velocity. Then now that we know this much, we can plug in to find the speed at the bottom. So 1 over 2 mv squared, cancel out m's, we isolate for v, is equals to gh2 the whole root. I'll just plug for my calculator because I'm lazy. Times. Also, don't let the ramp throw you out, catch you off guard, because the height here, the gravitational potential energy here, is all dependent on the height, like this height. Yeah, that's basically because gravity acts in this direction. Also, for this answer we want it in 2 significant figures, because 2 significant figures, so 8.9 meters per second. A pendulum is 1 second. Okay. So a pendulum is dropped from a position shown 0.25 meters above its equilibrium position. What is the speed of the pendulum as it bobs as it passes through its equilibrium position? I'm going to assume when it is at its equilibrium position, the gravitational potential energy is 0. I'm thinking of it the same way as when it hits the ground, where the gravitational potential energy is 0. So with that in mind, I'm going to solve this question. So E initial equals E final, as always. At the start, there is some gravitational potential energy. It is dropped. It is dropped. So it is at a rest when it starts, so there's no kinetic energy. And then when it's final, there's no gravitational potential energy, but there's kinetic energy. So let's find what the speed is. So and now I won't talk much like when I'm solving these questions, because they're all very similar. Maybe later down when the questions are a bit slightly different, I might like give my inputs. But for now, I may just quickly solve these questions. So we want how many? 2 sig figs per second. A box slides down at a frictionless incline as shown. If the box starts from rest, what is its speed at the bottom? Okay, so it starts from rest. So as always, E initial should equal E final. When it starts from rest, there's no kinetic energy, but it starts at a height, so there is gravitational potential energy. What height it starts from, we don't know. We'll have to find that out. We're given clues to help us find that out. So mgh equals v squared. The height we can calculate using trigonometry. So this height is opposite from this angle, so we can use sine to calculate that. So height should equal 12 sine 30, which equals 12 sine 30 is equal to 6. Very nice number. Okay, now with that information, we can just isolate for b. So it's g h 6. The answer should be 10.8, but it's 3 sig figs, so like yeah, 10.8 meters per second. Finally, a different looking question. So a roller coaster car starts from rest at point A. What is its speed at point C if the track is frictionless? Okay. So at point A, right, it looks like the roller coaster is at rest. It's gonna travel down and then reach point C. So at point A there is a gravitational potential energy. Initially equals E final. So at the beginning there's a gravitational potential energy, mgh. It doesn't seem like there's kinetic energy. It doesn't seem like it's moving at point A. So with that information, is okay. Let's find this in this E final. E final. So it looks like there is gravitational potential energy because 4 meters above the ground, and it also is moving. Well, it would be moving if there is speed there. So let's write mgh2 plus m1 over 2 mv squared. Let's cancel the m's and let's isolate for v. Okay, so gh minus gh2 over 2. It's not over 2, so times 2 is equal to v. So v is equal to, let's plug in x. Let's factor out the, let's factor out the g. 8 times 12 minus 4. So solve. 2 times 9.8 times 12.52 meters per second. I got it on my calculator, but it should be in 2 sig figs. So 13 meters per second should be our answer. So next question, a 2.5 kg object is dropped from a height of 10 meters above the ground. Calculate the speed of the object as it hits the ground. E initial is equal to E final. Initially it's dropped, so there is no movement initially, but there is a gravitational potential energy, so EP initial. Then it's dropped, and then finally there is kinetic energy. Man, all these questions are literally the same. Okay, it's okay. I'll find next question, like whole different questions. These are just questions I get from sources. So the potential energy is mgh, and then the next one is 1 over 2 mv squared. So m's cancel out. Let's isolate for v. 2ga whole root 9.8 times 10. What a nice number, 14 meters per second. But there should be 3 sig figs, right? So 14.0. Sig figs are so important because you get so many marks taken off if you don't recognize sig figs. Okay, now question 10. 80 kg student running at 3.5 meters per second grabs a rope that is hanging vertically. How high will the student swing? Okay, this is really interesting. So E initial equals E final. So it is initially, they have a they have kinetic energy at the start, they have kinetic energy at the end. There's no gravitational potential energy at the start, but there's gravitational potential energy towards the end. So let's see. So now with that in mind, it's kinetic energy. So 1/2 mv squared plus gravitational potential energy, which is 0. Towards the end, though, there's gravitational potential energy, which means mgh plus the kinetic energy 1/2 mv. Okay, I take that back. I don't think there is kinetic energy towards the end of the thing. I don't think so. There's kinetic energy towards the end, because when he reaches his apex of his swing, right, he'll be at rest in the air for that brief moment of time, so there will only be gravitational potential energy. With that in mind, let's solve for h. So h is equal to 1/2 v squared over g. Geez, thank God I caught that quickly. So 3.5 squared. .625 meters. But I need 2 sig figs, so that will be 0.63 meters. So next question. Okay, let's go. 2 more questions. A pendulum is 1.2 meters long. If the pendulum is pulled until it makes a 25-degree angle to the vertical, what's the speed of the pendulum bob when it passes through its equilibrium position? Hint, determine the vertical drop of the pendulum bob first. So now we have to find this vertical drop. Thanks for the hint. So since it is 25 degrees, the string is what? 1.2 meters long? 1.20 meters long. Since it's 25 degrees, we can solve for this. This makes a 90-degree angle. This is adjacent to this, so we can use cosine law to find it. So this side would be equal to, so the height, not the height, the drop. Oh yeah. Okay, that makes sense. So I find this position, right? Basically the height of this, and I subtract it from the length of this string, right? And that's how we'll get the drop. So basically over here is equal to 1.2 meters cos 25. Basically the height will equal 1.20 minus this. So I'm just going to factor 1.2, so it'll equal 1 minus cos 25. Height equals times cos 25. The drop is 0.11243 meters. With that in mind, I can solve for it. So okay, so at the start there is gravitational potential energy. At the end there is kinetic energy. So very similar to the other pendulum question we did. Cancels out. Solve for V, G, H, times 2, 9.8 times 0.11243 times 2, root of answer, say 1.484 meters per second. But sig fig should be 3, so it should be 1.5. No, what am I saying? 1.48 meters per second. That should be our answer. Okay, final question. So a new roller coaster has come to PNE in Vancouver, as shown in the diagram below. The speed of the roller coaster point A is 4 meters per second. What is the speed of the roller coaster point B? So let's see. So okay, these are very interesting questions. So there is a E initial equals E final. So initially, right, there is a speed, so there is kinetic energy initially. So 1/2 mv squared, and there's also gravitational potential energy since it's at a height. So mgh and E final. So at point B, seems like it's at the ground basically. So there is no gravitational potential energy, but there is kinetic energy. So V2. So now we cancel the m's out. We cancel the m's out, and then we isolate for the v2. So basically 1 over 2 mv squared, so 1 over 2 v squared plus gh times 2 and then whole root should equal our velocity. I'll just plug it into my calculator. Here, 2 times 0.5 squared plus 9.8 meters per second there times 5 which should give me 10.67 meters per second, which is 10 point, okay, there's 2 6 figs, so there's 11 meters per second. So now, is the roller coaster getting fast? So this part B of it, is the roller coaster going fast enough to get to the top of the second hill, point C? So then, okay, so basically, if it's part B and C, also they go hand in hand. So C also says how fast does the roller coaster have to be going at point B to make it to the top of the second hill. Second hill is point C, obviously. So now let's do it. So by finding point C, we can see point B. Okay. So basically so at point C, right? To reach point C, we can assume that the minimum speed it will take to reach point C will stop right here, right? The minimum speed will just get above to point C and it will stop. So there would be no kinetic energy at the top, but there would be gravitational potential energy at the top, right? So to get, so part C, so mv, 1 over 2 mv squared is equal to mgh. So cancel out the m's. So 1 over 2 v squared is equal to h. So the velocity, when if the velocity is greater than 10.67 meters per second, then the answer is no. The it's not fast enough to get to point C. But okay, let's solve for velocity. So 2gh. The height in this scenario is 8 meters. So 2 times 12.521 meters per second. So no, for part B, the answer is no. And for part C, it is required 12.521 meters per second. And why don't you need the mass of the roller coasters? Because as you can see in this energy equation, the masses can all cancel out. So you don't really need the mass in these questions to answer these two questions. So thank you. This is the end of the video.